So, as you're researching or shopping for a hot tub, you're going to find that most of the industry is still completely filling this entire cabinet full of foam. And the guys that are doing that are really going to try and impress upon you that more is better, and that filling this completely full of foam must be better insulation. Now, we don't argue the fact that a foam-filled tub is poorly insulated. In fact, a foam-filled tub is more than adequately insulated. But what we will try and suggest is that it is not necessary to blow the entire basement of your house or your home full of insulation to get your house insulated properly. You know, there's a law with regards to insulation called the law of diminishing returns. And what the law of diminishing returns suggests is that once you have enough insulation to stop the transfer of heat, then after that, the insulation value really does not get better. It's just more foam. And, you know, 3 to 4 inches of this 2-pound density urethane foam surpasses the law of diminishing returns as far as enough insulation to completely stop heat from transferring out of this cabinet. You know, the other thing that we should look at when we're looking at how well a tub is insulated is where the insulation is. You know, and if you look at your house, you know, the vast majority of the insulation is not in your basement. It's in your attic. And we'll talk about our cover in a video upcoming. But, you know, the insulation on top of the tub is every bit or more important than the insulation underneath. And we're certainly not putting 3 feet of insulation on top of this spa. Okay? So, once we're comfortable with this concept of insulating the perimeter, and it's very, very important to realize that that we don't put any insulation on the shell, we can start to talk about this concept that we use called heat lock. So let's talk a little bit about our heat lock concept. Here it is in a nutshell. Insulate the perimeter. Do not insulate the shell, and put your equipment in the insulated area in between. Take all of the heat that's generated by that equipment, have it insulated so it cannot get out of the cabinet, but because the shell is made of fiber glass, and we all know that glass transfers heat reasonably easily, have that heat all transfer through the shell and into the water. Now, let's back up and explain that a little more in depth. Electric motors, and this number varies a little bit, but electric motors run at approximately 65% efficiency. And here's what we mean by that. If we send X amount of energy to an electric motor, 65% of that energy gets transferred from electric energy to mechanical energy to basically push the water around this tub and give you a massage. But a full third, or the other 35% of that energy, is basically given off as heat. And if you've ever held your hand on an electric motor, you'll understand the fact that big electric motors generate a tremendous amount of heat when they run. So we take all of that heat, we trap it inside this cabinet, and transfer all of that heat through and into the water. And basically the bottom line is, that the heat from the motors when they run are capable of maintaining water temperature without the heating element having to run very often. In fact, if you go into any Arctic spa store, every Arctic spa store will run one spa with the heater either completely out of the spa or just disconnected. And an Arctic spa will maintain 104 degrees or 40 degrees Celsius, no problem, without even having a heater, because the heat from the motor will maintain that temperature. Okay? And the big benefit of this is simply the cost to run it. And in a hot tub, the big amperage draw, or the component that draws the most amperage, is the heating element. And when that heating element turns on, if you happen to be watching your electric meter, that's what makes the wheel go round. And in an Arctic, that heating element really doesn't have to run very often because the heat from the equipment is doing most of the work. And the bottom line is it saves you money every day in your running costs. Now, what's the rest of the industry doing? Everybody else is either spraying foam all over this shell or completely blowing it full. But they create an insulation barrier between the motor and the water so that all of the heat generated by the equipment can't get to the water anymore. And there really is only one alternative to do with it, which is simply vent it out the door. And in those spas, now the only heat source becomes the heating element, and that heating element has to run more often because it is the only heat source, and it has to do all of the heating to maintain the water temperature in this spa. Okay, so there's another big benefit of this concept of insulation, and it's more of a benefit in a cold climate than it is in warmer climates. If you live in any climate that does get below freezing, there's an automatic freeze protection built into this tub that you don't see in other spas. Here's how it works. In the event of a power outage or a pump fuse blowing or a breaker tripping, and these things do go wrong, and Murphy does say that, you know, it's more likely it goes wrong in January than in July. Anyway, if this tub ever shuts off in a freezing condition, the transfer of heat is reversed. The heat from the water radiates back into this cabinet, and it will keep this cabinet at the same temperature as the water for as long as the water temperature remains above freezing. In our studies, at 20 below, which is about 5 below Fahrenheit, 20 below Celsius, this tub can shut off, and we've got 5-ish days grace before anything underneath this tub would freeze. And so to recap, just quickly, this whole concept of heat lock. Insulate the perimeter. Do not insulate the shell, and let the heat transfer back and forth. There's some huge efficiencies by using the heat from the equipment to heat the water instead of venting it outside. And if you live in a climate that gets cold, there's a very important freeze protection built right into this spa that will protect you in times of trouble during cold weather.